All right, Chapter 7, Section 3, master level for slope point form. So now we're going to convert slope point form to slope-intercept form. So first off, given the slope and a point, determine the equation of each line using slope point form. So in each of these examples, I've actually given you the slope of the line, and I've just given you one point. Okay, and that is actually all we need. So remember, the formula for slope point form is y minus your y value is equal to your slope times x minus the x value, right? So let's try it for the first one. Okay, so we'll use this formula here. So my y value is 4, my x value is 1. So I get y minus 4 is equal to 3, and this is x minus 1. Okay? Now, it says to graph the line. We can do that. So we know that this is a point on our graph. X is 1, y is 4, so that exists here. Okay, and we're already given that the slope is 3, or 3 over 1. So I go up 3, right 1, up 3, right 1. I could also go down 3 and left 1. Doesn't matter. But I now have enough to graph my line. So I'll just put that in right there. Okay, and then this is the point that we actually used. I'll label it, why not? 1, 4. All right, so for the next one, we know the slope is -1, x is -2, and y is 7. So that's the only coordinate we're given. So let's use our formula. Y minus our y value is equal to the slope times x minus the x value. So watch your signs here. Okay, so we've got some double negatives in here, so I'm just going to tidy this up a little bit. Okay, now normally, in this case, if you have a -1 out front here, typically that's not written. We just leave a minus sign. But inside the brackets, that would read x plus 2. Because x subtracting -2 is the same as x plus 2. So that is the equation of our line in slope point form. So let's graph it. Our point is -2, 7. So that is right there. And we know our slope is -1, or -1 over 1. So we go down 1, right 1, down 1, right 1, and so on, and so on, and so on. So that is enough for our line. So this goes like so, just right about there. So there's our line. And the point that we used was right here. We could have used any point we wanted, but that was the one that was given. So I'll just label it -2, 7. So there we go. All right, last one. So y minus our y value, y minus -8 is equal to 1/5, that's our slope, times x minus -9. All right, I'm just going to tidy this up so we don't have any double negatives. So we get y plus 8 equals 1/5 times x plus 9. So there's our equation in slope point form. Let's plot it. So our point is right there, I think. Oops, no, it's not there. Let's see, it's down here, right there. That's our point. And our slope is 1/5, so I go up 1 and right 5. Up 1, right 5, up 1, right 5, and that's enough to draw the line in. So it goes like that. So let's put the arrows there. And I'm just going to make note, this is the point that we used. And this is -9, -8. Next, we want to convert each of these three equations to slope-intercept form just to verify that the above graph is correct. So, again, slope-intercept form is y equals mx plus b. So what we need to do for each of these equations is just to solve for y. Okay, so the first one we had y minus 4 equals 3 times x minus 1. Okay, so we need to get this equation, which is slope point form, to look like this. Well, we don't want these brackets, so let's apply distributive law and expand that out. So that's 3x minus 3. And now we just need to add 4 to both sides. So that's going to give us y equals 3x plus 1. Okay, so there's our equation in slope-intercept form. And you can see from the graph that it's correct. Okay, the y-intercept is 1, and the slope is still 3. Okay, for the next one, had y take away 7 equals negative, it's invisible, negative 1 times x plus 2. Okay, so let's apply the same technique here. Let's get rid of those brackets. So really it's just negative 1 times everything in here. That just changes all the signs. There we go. And to solve for y, we just need to add 7 to both sides. So that's going to give me negative x. And adding 7 to both sides, well, I get negative 2 plus 7. That is positive 5. Okay, so that is slope-intercept form. And if you look at the graph, you'll see that the y-intercept is 5, and our slope is still negative 1. Okay, the last one's a little bit trickier because we do have a fraction to deal with. Now, there's more than one way, so the way I'm showing you is by no means the only way. Okay, so just get the equation down here. That is x plus 9. All right, so how do we deal with this? So one method we can apply is, let's just get rid of the fraction. That doesn't mean our final answer won't have a fraction, okay, but at least for the time being, we don't have to work with them. Okay, so to get rid of this 5, we need to multiply everything by 5. Now I don't have enough room to squeeze it in here, so I'll just write it on the right-hand side here. Okay, the order, of course, does not matter. So distributive law here gives me 5y plus 40. Okay, and then here I have 1/5 times x plus 9 times 5. Well, the 5 over 5 just cancels, and the 1 in front, well, that doesn't do anything. So I actually just get x plus 9. Okay, so let's get y by itself. So I get 5y equals, and I need to subtract 40 from both sides. Okay, so this is x, and 9 take away 40. That is negative 31. Okay, we're almost done. We need to isolate y. So we need to divide everything by 5. So we actually are going to have fractions in our answers. Our answer, there we go. So x over 5, well, that's not reducible. There's an invisible 1 here. So you can write it as 1/5 with the x in the middle if you like. And then I have negative 31 over 5. That is not reducible. So you can actually just leave it as negative 31 over 5. Okay, so that is our equation in slope-intercept form. All right, so comparing this to the graph up above, well, it's obviously true that this is correct. The slope is 1/5. We already know that. But this, as a y-intercept, if you try and compare that to where the graph crosses the y-axis, this looks kind of ugly, 31 over 5. But what is that? Okay, well, remember, if you want, just for clarification, you can express this as a mixed number, a mixed fraction. So it is negative. I'm just going to write it over here. But 31 over 5, well, 31 divided by 5, that doesn't work out perfectly. But we know that 5 goes into 31 6 times. And there's 1 left over. Okay, so you could actually write this y-intercept as negative 6 and 1/5. So now you can actually look at the graph and see that that is where the line crosses, just below negative 6. All right, lastly, for each pair of points, determine the equation of the line passing through both points. Use slope point form. Okay, so here we have 2 points. If we had a graph, we could plot them, but we're going to try and do this without graphing. All right, so if we want to use slope point form, we need 1 point. Well, we actually have 2, so that's good. but we also need the slope. Well, unfortunately, we are not given the slope, okay? But because we have 2 points, remember, we can find the slope, okay? So let's first find the slope using the formula, x1, y1, x2, y2. So, doesn't matter, I don't know, maybe this could be x1, y1, x2, y2. So this would be negative 7 minus negative 1 over 3 minus 1. Okay, so let's simplify this. This becomes a positive 1, so negative 7 plus 1 is negative 6. And 3 minus 1 is 2. And this simplifies quite nicely. We get a slope of negative 3. Okay, so now we know the slope. So we can find the equation of our line, and we get to choose which point do we want to use. It's up to you. I'll pick the first one. Why not? So this is y minus my y value, remember y minus y1, equals my slope, which I now know to be negative 3. And this is times x minus my x coordinate, so that's x minus 1. And I'm done. Okay, I guess maybe I should do this. If this was an exam and the answer was in slope point form, it'd be written like that. Okay, so this would actually be preferred. If you chose to use this point, okay, your answer would look slightly different, but in fact it would be the exact same line. Okay, let's try another one. So we have 2 points. We want to determine the equation of the line that passes through both of those points. We want to use slope point form. Well, we have 2 points, but we have no slope. Okay, so we need to figure that out. So this is my x1, y1, x2, y2. So let's figure out the slope. All right. So we have negative 4 minus negative 1 over 7 minus 1. So let's work that out. This becomes plus 1, so I get negative 3, and 7 minus 1 is 6. So this, of course, reduces. I get negative 1/2. So that's my slope. So now to finish it, to get my equation, all I need is to use one of these points. It's totally up to you. The first example, I used this point. So for this, I'm going to use this one. Again, doesn't matter. So I get y minus my y value equals my slope times x minus the x value. There we go. But probably we'd want to write it like that. Okay. We're not asked to convert it to general form or slope-intercept form, so this is good. And for this one, I know I boxed the other one, but this one is preferred.